Okay, let's start with the first question for the homework. Homework 2. A cell is connected to a lamp as shown. We have positive and negative. A charge of, this is a charge Q, 4 coulomb, flow through the lamp in 2 seconds. We have time. What is the direction of electron? Electron will move from negative to positive. This is the direction of a charge flow through the circuit. So electron will be from left to right. Okay, what else? And what is the current? Current I equal charge over time. Charge in coulomb and time in second. So now we have 4 over 2 equal 2 amps. So I will choose A. Let's move to the next. Which components are represented by P and by Q? P is a thermistor, Q is fuse. So I will choose A. Easy question. The circuit shows a 12 volt battery connected to lamp with a resistance 3 ohms. How much energy is transferred to the surrounding by the lamp in 2 minutes? So first you have to convert time from 2 minutes to second. 2 multiply 60 equal 120. Okay, now if you want to find energy equal V multiply current multiply time. Okay, so first you have to find the current. Okay, current equal V over R. Voltage is 12, R is 3, so now current is 4. Now again energy equal volt 12 multiply current 4 multiply time 120. So now what is the answer? The answer will be 5760. This will be D. The circuit showed in the circuit shown there is a current of 10 amps. How much charge passed through the resistor in 2 minutes? Again 2 minutes, it means you have to convert to second, multiply 60 equal 120. Now what is a charge? Charge equal I multiply T. It will be I 10 multiply 120 equal 1200. Next. In the circuit diagram showed a circuit with an AC power supply, a diode and a resistor. As you know, diode, what diode makes? Diode, if we have alternating current like this, when it enters the diode, it becomes rectified current. It will be positive in only one direction. And this is the function of diode. So this is why I will choose B. Because he said, which diagram showed how the current in the resistor varies with time. So as I said, the diode let the current flow in only one direction, which is positive in this case. Okay. Four circuits, each contain a 6-volt battery, a diode and a meter and a lamp. None of the components is faulty. Which circuit shows a possible ammeter reading? Okay, so all devices is working. We have a diode. Diode allow current to flow in only one direction, the same direction of what? Of the arrow of the diode. So as you see, if I have positive, the current move from positive to what? To negative. So now I have current in the same direction of diode. Now I have current here. So this will be correct. What about the second one? I have positive, so the current will move in the same direction of diode, as you see. So, but he said reading is 0, so this will be wrong. So A is correct. Okay. If you move to C, now you will find positive. So now the current is against the direction of diode, so no current flow. So this will be wrong. Also, because current is positive now, we have to move current from this, so it will opposite to the direction of diode. So also we don't have a current here. The diagram shows a circuit used to make a light detector. If you want light detector, you have to use what? Light dependent resistor. So one component is connected with XY, which component causes the ammeter reading to increase when light gets brighter. Now I would choose what? The sensor for light, which is LDR, light dependent resistor. This is the symbol of LDR. A student connects the circuit shown, which graph shows that variation with time of the current in the resistor. As I said, if we have a alternating current, positive, negative, positive, negative, it will be out. While it passing through the diode, it will become what? Just in one direction, positive only. So this is why I will choose B. Okay, A is incorrect because now we have only one diode, so we have a current flow in one direction, but diode will cancel negative, so negative will be 0. So I can't choose A. B is correct. A diode is used as a rectifier. What's purpose of rectifier? Rectifier change alternating current into direct current. Alternating current with two directions to direct current with one direction. The resistance of a component in a circuit is found using an ammeter and voltmeter. How are ammeter and voltmeter connected? As we said, ammeter is connected in series like this. I will draw a circuit for you. This is ammeter connected in series, okay? And if we have a lamp, okay, where we can connect the voltmeter, it should be connected in parallel. So I will choose C, voltmeter in parallel with component, and ammeter in series with the component. Which diagram shows a current voltage characteristic for a filament lamp. As I said, filament lamp, as current increase, temperature increase, so resistance increase. Now we have a curve because resistance increase, so the curve must be toward the voltage. Because as you know, in this case, R is a change in volt over a change in current. Okay? The diagram shows part of an electric circuit. The reading on the voltmeter is 16. We have voltage 16. The current in the resistor is 8. 1 coulomb, so charge equal 1 coulomb of a charge flow from P to Q through the resistor. How much energy? Because as you know, energy or work, electrical work equal charge multiply voltage. We have 1 coulomb multiply 16 volts equals 16. So the answer is what? 16 joule. The circuit diagram shows a cell connected in series to resistor and a component X. What is component X? All of you know this is diode. The diagram shows a circuit component. What is used for? As you know, this is diode, and the diode is used to what? To convert from alternating current to direct current. Allow current to flow only one direction. Allow current in one direction only. Okay? Diagram 1 shows a circuit containing an AC power supply and unknown component X and a fixed resistor. The graph in diagram 2 shows how the potential difference across the resistor varies with time. Now we have current move or travel in only one direction, so it must be here. You have to put diode because diode allow AC to flow in only one direction, so C is correct. In the circuit shown, the ammeter reads, this is ammeter reading current, and the voltmeter we have voltage. How much energy transferred in 10 seconds? So as you know, energy equal VIT. So 2 multiply 12 multiply 10 equal to 40 joules. A student is to determine the resistance of resistor R. She used a circuit including a voltmeter and ammeter. Which circuit should be used? All of you know that ammeter is connected in series and voltmeter is connected in parallel, so D is correct. State in terms of their structure why metal are a good conductors of electricity. Because metals have free electrons. Okay, next. A cylindrical metal wire W1 of length L and cross-section area A has a resistance of 16. So now we have R1 16. A second cylindrical wire W2 having length half and cross-section area 2A is made from the same material. Determine the resistance of wire W2. Okay, now you have to put the given like this. We have wire 1 and we have wire 2. We have resistance, length, cross-section area for 1, resistance, length, cross-section area for 2. Now, what is the given? He gave us resistance R1, 16, and the length is L. The cross-section area is A. Now, what is the change? He asked it to find R2. What is the change? He changes the length to be half. So we have half L and double cross-section area 2A. So first you have to know what is the change in length. Change in length L2 over L1. So we have half L over L equal half. What is the change in area? Change in area is A2 over A1. So it's become 2A over A. It becomes 2. Now, if you want R2, you have to multiply the old resistance and a change in length over a change in area. So it will be 16 multiply change in L is half over change in area is 2. It will give you 4. So the answer now is 4 ohms. After a very long period of use, the wire filament of one of the lamps become thinner. Thinner means cross-section area decreased. So as you know, what is the relationship between resistance and cross-section area? Inversely proportional. So decreasing cross-section area will increase the resistance. So I will choose resistance increase. Figure 6.1 showed a shower that takes in cold water. The water passes through an electric water heater and emerges from the shower head at a higher temperature. The power, he gave us the power P. The shower is powered by, we have a voltage. Now what is the unknown? He asked to find what is the current. All of you know what we have. This triangle power equal I multiply V. So if you want to find current, it will be power over what? Over voltage. So now we have 9,000 over 230. What is the answer? You have to use your calculator. Okay, now find the answer using your calculator. $39. Okay, it will be 39.1, but you have to round it to two significant figure, 39 amps. Let's move to the next. When fully charged, this is the voltage. Rechargeable battery can deliver a current of, this is the current, but be careful, this current is in milliamps. So you have to convert it to, so 210. It will be divided by 1000. So now we have current 0.21 amps. For 10 hours, this is the time, 10 hours. Okay, and they ask it to find what? Calculate the charge. Charge equal current multiply time. Okay, current is 0.21. Multiply, what is the time? Time is 10, but 10 hours. So you have to convert from hour to second. you have to multiply in 3600. Now what is the final answer? Final answer will be equal 9072 column. You have to use two significant figure as he gave you in the question, so you have to round it to 9100 column. Don't forget to use two significant figure. Calculate the energy stored in the battery. He asked to find energy. Okay, you can write energy equal V multiply charge. V is 1. Sorry, I have a mistake here. Okay, because this answer is not, this answer using my calculator give me 7560. You have to round it. Okay, now if you want to complete the question, V is 1.2 volt multiplied charge. I will use this one, 7560. What is the answer? 9072. I will round it to 9100 joule. An electric kettle contains water in a temperature. The kettle has a power. We have a power, but be careful because this power in kilowatt. Okay, so power equal 3 multiply 1000. Now it becomes 3000 watt before using it. And switch it on for 3 minutes. What is the time now? 3.5 minutes. You have to convert it to second. Multiply 60 equal what? Equal 210. Now he asked to find, calculate the energy supplied to the kettle. Energy equal power multiply time. Power is 3000 multiply time is 210. Okay, so now what is the result? 631,234 joule. You can write it as also 630 kilojoule. It will be okay, no problem. Figure 8.1 shows a negatively charged conducting sphere. So the first two marks, don't forget to look to the marks. Draw the electric field pattern around the sphere. As you know, this is the shape of electric field pattern around the charge. It will be straight lines like this. But don't forget the direction. The direction it into towards the negative. Out of positive into negative. Now, the current in electrical device is 0.21. So we have current equals 0.21 amps. Calculate the charge that flew during, he gave us the time is 75 seconds. And they asked to find the charge. So charge equal I multiply. Don't forget to write the equation. You will gain 1 mark at least if you have a mistake. Okay, so now 0.21 multiply 75. What is the answer? It will be 15.75. Don't forget to write it in two significant figure because this is a given is two significant figure. So it will be 16 column. Now explain what's meant by electromotive force, EMF. As we said, it is the work done or the electrical work done per unit charge to what? To move around the whole circuit. Okay, this is a definition. You have to memorize it. Now let's move to the next. There is a current in a wire of 0.65 milliamps. Pay attention. We have a current in milli. You have to convert it to, now we have 0.65 divided by 1000. Now it will become 6.5 6.5 using your calculator, multiply 10 power negative 4. Okay. Okay, in 2 minutes, what is the time? 2.2 minutes. You have to convert it to second, multiply 60. It will give you, I have to use my calculator again. So now 2.2 multiply 60 equal 132 second. Now we ask it to find the charge. Again, charge equal I multiply time. So it will be 6.5 multiply 10 power 4 multiply 132. So the answer is what? 0.0858. You have to use two significant figure only. So it will be 0.086 coulomb. Let's move to the next. Figure 1.1 showed an electrically powered bicycle. Okay. When fully charged, the battery can deliver a power of 600. This is the power for 60 minutes. Again, time equals 60 multiply 60 because it said 60 minutes. So now 3,600 seconds. Calculate the energy. Energy in joule. Energy equal power multiply time. So power is 600 multiply time is 3600. What is the answer? 2161234 zeros. You have to what? You have to write it in two significant figures, so it will be 22123450 zeros. Okay? Now let's move to the next question. Say the name of component A. Component A, as you know, diode. Okay, easy question. Now he said, mark with an arrow labeled E the direction of the electron flow in component B. As you see, electron will travel from negative to positive. And we have a diode. Diode, to allow current to flow, it must be positive. This terminal must be negative because current flow in only one direction, this direction. If you want the charge direction, charge will be in opposite direction of conventional current. So if you talking about the charge direction, electron direction, so I will write here E. This is E. Okay? Okay. Now, so with an arrow labeled E, the direction of electron flow through the component component B, sorry. So this will be this arrow. Okay. What about with an arrow labeled I, the direction of conventional current through component C? This is component C, so this will be component C. Now we have, this is the current direction. Okay, this is why we choose these directions. Okay, I don't have any question here, I think. Okay, maybe he asked it to draw here, so I will draw here for this, for what? For current, and I have to remove this one, and this will be for the electron, it will be electron E. Figure 8.4 showed a circuit with a component B and C connected to the direct current DC power supply for electromotive force 12 volt. 12 volt. Okay. Now the current in a circuit is 0. This is the current 35. Calculate the power delivered by the power supply to the circuit. So now power equal V multiply I. So it will be 12 multiply 0.35. Using your calculator, what is the answer? The answer will be 4.2 watt. So the answer will be 4.2 watt. Now we have finished all questions and the homework. Good luck for all. Try to correct your mistake. If you have any question, you can send your comment on YouTube, on Google Classroom, as you want. Okay, as you like. See you in the next homework, inshallah. Okay, goodbye.